Okay, this is sections 1 through 6 in the lesson plan. I'm going to go ahead and go back over 1 through 3 as I have chosen 2 new standards. I feel they go much better together in the lesson. I'll be able to deliver the content much more effectively, and the students will, I think they'll be able to better grasp what is going on as compared to the first 2 standards that I felt like I was having to nitpick around and they were being forced together. So looking at the first standard, rearrange literal equations using the properties of equality, and the physical science standard is calculate force, mass, and acceleration using Newton's second law of motion. So right there we can see that they tie in together pretty well. And then the objectives, the student will be able to identify the variable in a literal equation and apply the appropriate mathematical steps in order to solve for a given variable. The student will also be able to rearrange Newton's second law of motion to solve for force, mass, or acceleration depending on what is requested. So that right there pretty much covers both. That covers both standards. Using Newton's law of motion, we can have the students solve. Say I want to have them rearrange to solve for acceleration, so they could use the knowledge over one-step equations that would have been covered leading up to this lesson, and they're able to solve for acceleration. So why have you chosen this objective or objectives? I chose this objective because solving for an unknown variable is a foundational skill the students must have for future education in mathematics and science. This objective will provide students with great exposure of the relationship between the mathematics and science field through solving literal equations, specifically Newton's second law of motion. Student grouping. Initially, I will use whole group instruction with the students to go over the objective and examples with the students. Students will then be paired with their peer next to them and use a simulator to visualize the mathematics in action. The simulator that will be used is from the PHET Interactive Simulations website, or the FET. They may call it FET. I'm not sure on that. Students will then work individually with the simulator for independent practice. The lesson will conclude with group discussion over the acceleration values each student obtained from their simulation trials. This will involve students interacting with other students to compare their acceleration values and determine who in the class simulated a problem with the greatest acceleration. Why have you chosen this grouping? So the whole group instruction will be most effective for delivering objectives and problems worked through as it pertains to everyone in class. Pairing will benefit the students as they work with the simulator and engage in discussion over the mathematical steps as well as the literal equation. Force equals mass times acceleration. I will move around the class answering specific group questions as well as reviewing the progress of each group. Through individual work with the simulator, students will simulate their own problem and record the results. This will help in assessing where each student stands with the material. The class will conclude with group discussion over the simulation results to sum up the material that was covered during the lesson. So what teaching methods we use for this lesson? Explicit teaching model, cooperative learning, or pairing, simulation, class discussion. Through the explicit teaching model, it will be used for teaching the class as a whole sequential mathematical steps to solve for a variable and its application in solving literal equations. The cooperative learning or pairing, students will be paired in order to practice the mathematical steps used in solving literal equations for a given variable through utilizing a simulator. Students will discuss and digest the material with a fellow classmate in order to hear the process from another student's perspective. The simulator will offer visual aid in the applications of the material to students compared to just seeing the equations on paper. Class discussion, students engage in social interaction and assist in summing up the material for the lesson. So the activities, section 4 is the activities. So what activities have you planned? For the introduction, students will share their previous knowledge of solving one-step equations, and I will present a short presentation introducing literal equations. So looking at why I have chosen these activities for the introduction. So I want students to I want them to pair up with their partner and I want them to solve a one-step equation. That's the previous knowledge that they need to retrieve in order to move forward with the literal equations. So they can solve a one-step equation, give it to their partner for check and assessment, see if their partner agrees. If not, they can figure out what went wrong. And once they cover that, once we have a quick review over that, we'll go into the introducing literal equations. And they've probably seen, I'm sure they've seen in physical science, they've seen Newton's laws. They cover, in fact, in physical science, they cover physics, the physics chapters at the start of the year, and then they move on to the chemistry after the Christmas break. So they will be exposed to the Newton's laws. Students. So for the guided practice, let's move back up to the activities, the plan. So the guided practice, students will work in a pair and use a simulator. And then why have I chosen the simulator? The simulation offers students visual aid of real-life scenarios where literal equations are used. So I think the simulator just ties back in, or it ties the math and science together. It gives them a visual aid to see what's going on, to see why we use the equations. And it's just great exposure for the students to see why we're doing this, and some of the technology that we have out there that's able to guide them along, to aid them in understanding the equations and what they're there for. The independent practice. So once again, going back to the simulator, after they work with their partner on the simulator, they'll work independently to come up with their own trial. And in the simulator, they're able to change the force. As a person pushing objects like a box, a refrigerator. You can stack the boxes, you can stack the refrigerator, or stack the masses. And being able to change the force and the mass, they can rearrange Newton's second law, which covers the Algebra 1 standard, rearranging literal equations. So they can rearrange the literal equation to solve for acceleration, and then they're able to plug in the force and mass that they use for their trial and find what the acceleration is. The simulator does not give them the acceleration. It gives them a bar, and it moves. It's got a gauge, so it moves based on I guess magnitude, but it does not give them a specific the quantity of the acceleration. So they would have to use the mathematical steps in order to find that and solve for that number, the acceleration number. And in the closure, so after they have worked through their own trial in the independent practice, I want them to go around the class and compare their acceleration results with their other classmates. And I want to narrow down who in the class has the greatest acceleration, and we're going to use that trial to kind of cap the lesson off in review. We're going to break that problem down and see how they found out, or how they found that acceleration value. So it kind of gives them way, just a little bit of competitiveness. I wouldn't really say competitiveness, but gives it a little spark to see who, I would say bragging rights, but just gives a little enthusiasm to the class to see who has the greatest acceleration, and a good way to kind of review and sum it all up. So the materials. What instructional materials will you use, if any? So a class set of Chromebooks or laptops for group and individual activity. So each of them will need either a Chromebook or laptop. They're just accessing a website, the PHET website, to use the simulator. It's all online. So a Chromebook will be perfectly fine. And they'll each need one due to the individual practice. Pencils and paper for group and individual activity. They'll need that, of course, to record the results from their trial simulation. And then the projector smartboard for whole group presentation. So I'll be using that for after they work their one-step equation, a quick review, and then move into the introduction to literal equations. before they move on to the simulator. Alright, and that I covered. So why have you chosen the materials? That's pretty much what I just went over. So the evaluation is how and when do you plan to evaluate student learning on the content of this lesson. I'll use formative assessment during group and independent practice. They're questioning and analyzing the work of each student. This includes observing students as they work alongside their classmates during cooperative learning. So I can evaluate them on their teamwork. That's going to be that'll be crucial in the class, or any class for that matter. I will also administer a quiz at the conclusion of the week that will assess student knowledge over the material. So not only will I assess them, and I'll go ahead and go into why I've chosen this approach for evaluation, but I'll be able to assess them as they're working with their partner, through teamwork. I'll be able to assess them as they're working in their individual practice, through coming up with their own trial and seeing how well they're doing at that point after they've had practice with their partner and working with the simulator. And then additionally, this formative assessment will help me guide the direction of the next day's bell ringer problems. So once I see where they're at, and I can catch any confusion that comes up during their guided and independent practice, I can start formulating some problems for a quick review in the next day's bell work. And then for the quiz will assess students' understanding of the material and better prepare them for the summative assessment at the conclusion of the unit. So the quiz will be, it'll give them good exposure to what is to be expected. What exactly do they need to know for their summative assessment at the end of the unit or into the chapter whenever it's appropriate. So this is the review of sections 1 through 6, the coverage over those sections. I feel it's more, like I said at the beginning, the standards, they harmonize so much better than the last two standards that I had picked. Like I said, I felt they were being forced together, and I was having to nitpick the physical science standard, and it just, from my perspective, looking back at it, I've already seen it, so I could get away with that lesson. But for students, they were just now being introduced solving one-step equations, and then nitpicking science equations and throwing them in there. It would be mass confusion, I believe. So that's why I went back and reevaluated the two standards that I'm using for the lesson plan. And I feel that these two standards do a much better job of incorporating two disciplines and being able to put them together for a complete lesson. So that's it. That's 1 through 6.